Good morning, students. Today we will discuss the colligative properties of solutions. So, last time we have already discussed ideal and non-ideal solutions, deviation from the ideal behavior. So, the students, come to the point, colligative properties. First of all, we have need what is colligative properties. So, colligative properties. So, colligative properties are are those properties those properties which depend upon the number of particle, not on the nature of particle. Clear? Means, just we can say colligative properties. Shortcut we can say colligative property, CP means colligative properties, is directly proportional to number of particle of solute. Clear? So there are four types of colligative properties. First is relative lowering of vapor pressure. Relative lowering of vapor pressure. Second one, elevation of boiling point. Elevation of boiling point. Third, depression in freezing point. And last, fourth one is osmotic pressure. Clear? There are four types of colligative properties. First is relative lowering of vapor pressure. Relative lowering of vapor pressure is also known as a RLVP. Clear? We have already discussed the RLVP in second law of Raoult's for non-volatile solution. Clear? So, dear student, we will discuss one by one the four colligative properties of the solution. First of all, for your attention, please listen again. Colligative properties are those properties which depend only on number of particle, not on the nature of particle. Now the question arises, what do you mean by nature of particle? The nature of particle means the particle is acidic, the particle is basic, the particle is neutral, the particle is alcoholic, etc. and etc. And what do you mean by number of particle? Number of particle means total concept about the concentrations, mole fraction, molality, normality, and etc. and etc. Clear? So one by one, first of all, we will discuss about the relative lowering of vapor pressure. So dear student, the first colligative property is relative lowering of vapor pressure. So according to Raoult's law, for non-volatile solute. Remember the second law of Raoult for non-volatile solute. According to this law, the total pressure of solution, PS, P pressure, S means solution, the total pressure of solution is directly proportional to mole fraction of solvent. By removing the proportionality constant, we get PS equals to P naught B XB. Clear? Where PS equals to total pressure of solution. Total pressure of solution, while xb equals to mole fraction of solvent. Clear? And while p naught b equals to pure phase of vapor pressure of solvent. Okay, now we have P total of solution, pressure of solution equals to P naught B x B. Okay, now we know very well XA plus XB equals to 1. So XB equals to 1 minus XA. XB equals to 1 minus XA. So we have P total equals to P naught B XB. So XB equals to PS divided by P naught B. But XB equals to 1 minus XA. This is equation first. Put the value of XB. Put the value of XB in equation number 1. So we get 1 minus XA equals to PS divided by P naught B. Clear? So P naught B minus XA equals to PS divided by P naught B. So now transport the value. Transportation of XA into right hand side. So we get P naught B equals to PS divided by P naught B plus XA. Clear? But also transporting the PS divided by P naught B into left hand side. So we get P naught B minus PS divided by P naught B. Why? Because PS divided by P naught B in plus, after that by interchanging left hand side it will be minus. So it will be equal to mole fraction of A. Clear? By substituting the value of XA, this is equation number 2. By substituting the value of XA in equation 2, so we get, clear? Then it will be, on simplification, the equation will P naught B minus PS divided by P naught B equals to XA. And we know very well about XA. XA equals to NA divided by NA plus NB in terms of mole fraction. So for a dilute solution, Na is less than Nb in case of solution. So Na can be neglected. So it will be XA equals to Na divided by Nb. Clear? Where Na and Nb is, Na is number of moles of A, where Na is equal to number of moles of solute, while Nb is equal to number of moles of solvent. Clear? So by putting the value, this is equation number 2. This is equation number 2. By putting the x value of xa in equation number 2, then we'll get Na divided by Nb equals to P naught B minus Ps divided by P naught B. Clear? And we also know Na, number of moles of A, is equal to given weight divided by molar mass, while Nb is equal to same Wa, it is Ma. Nb is equal to given mass divided by molar mass of B. By putting the value in equation number 3, we get Wa divided by Ma divided by Wb divided by Mb equals to P naught B minus Ps divided by P naught B. So it will be by multiplying 1 to 4 and 2 to 3. So we get Wa multiplied by Mb divided by Wb multiplied by Ma equals to P naught B minus Ps divided by P naught B. So finally we get P naught B minus Ps divided by P naught B equals to Wa multiplied by Mb divided by Wb multiplied by Ma. This is the first derivation of RLVP, and this is so important because on the basis of this derivation a lot of numericals form in the board examination. So this is important for all of you. Clear? Now the second colligative property is elevation of boiling point. So dear students, first of all we have need what is boiling point. What is boiling point? Boiling point is the temperature in which vapor pressure of liquid is equal to atmospheric temperature. Clear? Boiling point, the temperature of liquid in which vapor pressure of liquid is equal to atmospheric temperature is known as a boiling temperature or boiling point, represented by Tb. But in case of solutions, suppose in case of water, we know water is solvent, polar solvent, and the boiling temperature of water is 100 degrees centigrade. Clear? But in case of solution, or just you can say in case of impurity, when we are going to formation of solution, then water is pure, and by mixing the solute water will be impure because of some amount of solute. So solute is equal to salt. By mixing salt plus water, it will be form solution, and we know the boiling temperature of water is 100 degree. Clear? So after mixing the salt, the boiling temperature will be increases slightly. Clear? Why? Because of after mixing the impurity in water, vapor pressure will be decreases. Clear? Why? Because of we also know the vapor pressure of pure solvent is greater than that of impure solvent. Clear? Then suppose after mixing the salt in water and the vapor pressure, the boiling temperature of water is 100 degrees centigrade. Clear? So the boiling temperature of solution will be slightly greater, 110 or 115 degrees centigrade, slightly depend upon how much amount of salt we are going to mix with water. Clear? So we will discuss about elevation of boiling point on the basis of graph, on the basis of graph. Suppose this is the graph. Clear? Suppose this is the vapor pressure, and this is the temperature. We are going to plot a graph between vapor pressure versus temperature. Suppose in case of water, we are going to mixing salt plus water. Clear? Suppose this is the amount of pressure. Suppose this is the vapor pressure of water. This is the atmospheric pressure. Clear? Okay. Now this is the temperature, 25, 50, 75, 100. Suppose this is 25, this is 50, this is 75, this is 100. Clear? If we plot only graph with water, so it will normal temperature, the vapor pressure of water will be this one, and as increasing the temperature, vapor pressure will also increases, it will be increases. And when the vapor pressure is equal to atmospheric pressure, this point, this is the line of this line is the atmospheric pressure line, and as increasing the temperature, vapor pressure will increases. Why? Because we know temperature is directly proportional to pressure. As well as increasing the temperature, pressure will also increase directly proportional to temperature. Clear? So as increasing the temperature, pressure will also increase, and the point in which the vapor pressure of water will equal to atmospheric pressure, this will be known as this temperature is known as a boiling temperature. Boiling temperature of water. Clear? Okay. Suppose this temperature is 25 degrees centigrade. Clear? So by mixing the salt with water, boiling temperature will decrease. Clear? So this one, suppose this is the temperature, 25. Okay. Now by plotting a graph, it will become this one. When vapor pressure of this black line represented solution, and this green line is represented water. Clear? This is boiling temperature of water, and this is boiling temperature of solutions. Okay. So this temperature is boiling temperature. This is also boiling temperature, but it is boiling temperature. B means boiling, P matlab point of solution, boiling point of solution. Clear? By mixing the line with lower part, this one, we get two lines. First one this one, and second one this one. Suppose this one is the T0 B temperature. T0 means pure boiling point of water, and this is boiling temperature of solution, TB. So this is the difference between solvent and solute. Clear? This is boiling temperature of pure solvents, and this is boiling temperature of solutions. So this difference is due to presence of solute. This difference occur due to presence of solute by mixing the solute, and we are taking, in case of solute, we are taking salt. Clear? So this graph represent here the boiling temperature. So how much amount of difference? We get TB minus T0B equals to delta TB. And this delta TB is the elevation of boiling point. point. Clear? Elevation of boiling point. So further, the elevation of boiling point delta TB is directly proportional to concentration of solute. Clear? Why? We know very well the pure amount of solvent have boiling temperature is lower, and after mixing the salt with water it will be greater due to concentration of salt. The elevation of boiling point becomes larger due to concentration of solute. Okay, so the terms of concentration taken by the scientists, delta TB is directly proportional to m. Now what is m? Where m is equal to molality. Clear? So by removing the proportionality constant, delta TB equals to Kb multiplied by m, where Kb is equal to bluescopic constant. Bluescopic constant. This is bluescopic constant Kb. Clear? Now we know the terms molality. Molality equals to moles of solute. We have already discussed in first lecture. Moles of solute divided by mass of solvent in kg. Mass of solvent in kg. So moles of solute Ma divided by Wa, and mass of solvent equals to Wb in kg, or just you can say Wb multiplied by 1000, but Wb will be in gram. Clear? So dear students, m is equal to Wa multiplied by 1000 divided by Ma multiplied by Wb. Clear? This is in terms of molality, and molality is the concentration terms in which moles of solute divided by volume of solvent in kg. Clear? So it will become delta TB equals to Kb multiplied by Wa multiplied by 1000 divided by Ma multiplied by Wb. Why? We know because of delta TB equals to Kb multiplied by m. This is the main formula. By putting the value of m in the equation, we get Wa multiplied by 1000 divided by Ma multiplied by Wb, where Wb will be in case of gram. If you are taking Wb in kg, then this 1000 will be neglected. Clear? So this is elevation of boiling temperature. This is important for NEET. This is important for JEE. This is also important for AIMS. Share, subscribe, and press like button. Have a good day ahead. Thank you.